Good morning, everyone. It's an honor to be here talking about a topic that's really dear to me. I just wanted to share some reasons that as an architectural student, this became a passion for me, a long-term passion. As I was studying in India, I found that a lot of the architectural studies focused on new materials, new design. It was becoming more fashionable to look towards the West, to kind of look at all the glazing, all the concrete, all the designs that we have here. And I had the opportunity in my 5th year to take a 6-month break to actually do a research project to look at some of the ancient architecture projects in examples in India. And I found that it was really interesting. As I kind of practiced architecture, I keep going back to some of those ideas that I saw in some of these 400, 500-year-old examples of building structures. They were not called green. They were just, they were just a simple structure and spread out in different parts of India. Like I would right here. If you can see some of these examples, this is typical southern India construction, where you have an immense amount of rain, and as you know, India is a very hot. It just goes hot, hotter, and hottest, and so there is really no. The weather there is pretty brutal, and if you look at the amount of overhangs, and the thing that I really like about these photographs, and like I mentioned, these are 400-year-old structures. So these are 400-year-old structures, and if you look at them, they have these roof overhangs, and if you notice, none of these have gutters, right? In the US, we love gutters, we love to have downspouts, and the water being taken away. I wondered how these actually sustain themselves, because there is torrential rain over there. It just rains, pours through the year, and how do these buildings actually are so durable? Well, one of the things is that they have these massive overhangs which help cut out the sun in the summer, which is part of the passive solar design, right? And so they cut out that sun, but at the same time, these overhangs go about 2.5, 3 feet across the building, that there is the water just sheets away from the roof to away from the building. And they never need a gutter system that you need to clean, you need to maintain, and then you need to spend so much money. Down here, these are examples of like how they have inner courtyards in buildings that protect them from the sun. These are some more examples. These are really interesting. Even the town planning, there is a village in southern India that I studied as part of my thesis, and it is brutally hot there. It's 110 degrees, okay? And when you walk outside in areas around here, you practically feel like you're getting a heat stroke. But when you walk into some of these streets, if you notice, these streets are never straight. They are not east-west or north-south. They kind of stagger. They kind of break the whole journey across them. And the interesting thing about it is that the wind, if you're looking at that particular picture, the wind is kind of going from here. This is the windward side. That's the leeward side at the far end. And when the wind goes through these narrow streets, what happens is it kind of narrows down, constricts, and then at certain points, all along these streets, there are these big banyan trees that are located along a courtyard. And what happens is that suddenly, once the wind is going through these narrow constricted streets, it then opens out and expands and rejects all its heat to all that greenery, specifically located in that particular courtyard. And it suddenly cools down, and there's this really great waft of cool air that surrounds everyone, even in 110-degree Fahrenheit weather. So these things were very interesting to me. I mean, kind of helped formulate my ideas as to whether like these modern structures are really what we needed in our cities. Because if you look at concrete, concrete has practically a 0 R value, which is resistance to heat flow. It is 0.5. The lower you go, the more heat flows through the structure. Now, in a climate like in India, if you have concrete as the dominant material, then what happens is you have huge amount of air conditioning loads in a building. So the way I look at it is that I think in the last 100 years, we have kind of forgotten some of the wisdom that we have learned from our own communities and rejected it in favor of technologies, because we feel the HVAC technology, the heating, cooling, and the energy costs have enabled us to be bold, very, very bold in our design, and we like that. And we don't want to be stopped by what we had hundreds of years ago, which is kind of filtered down to some really good examples of how we should build. So now we have so many different prototypes, right? I mean, when you look at residential, it's multifamily, single family, row housing, condos. So there's a lot of challenge when you're looking at residential design, when you're trying to make it high performance or low energy. So this is a project that I was involved with many years ago. This was actually slated to become a maintenance facility for the city of Columbus, and the neighbors protested and said, hey, no, we don't want this in our backyard. And so in a really good political move, Mayor Coleman at that time, former Mayor Coleman, he decided that he wanted to create an example of green building, a green neighborhood as a legacy for himself. And so he announced this project. It's called Greenview Estates. It's off of Agler Road and in sort of near the airport area. The interesting thing about this project was that the collaboration was with actual builders, production builders. We sat down at the table with them and said, look, we are bringing all these technologies, high performance technologies. And high performance technologies, I call them green building, because to me it means that you have very less impact on the environment. So we call that green building technologies. And so we sat at the table with these production builders, and they were built. Each of these 30 homes were actually built by production builders. And we created a specification tailor-made for this particular project. And as you can see, some of the areas that we focused on. So this is the other project. So going back, so this was really the first example. Then moving on, there was a project that the organization that I founded in 2003 called the Columbus Green Building Forum. We got involved with Columbus Housing Partnership on 21st Street. It's 258 North 21st Street. It's still there. It's owned by a very proud homeowner. And it was a really interesting collaboration of volunteer work and industry participation and sponsorship. So in this particular project, it's a small, really small project. It was a 30-foot by probably 100-foot deep lot that we had. So you could see it here, very narrow lot. This is the front, and it kind of like goes pretty narrow. So this is the house. We had solar panels and hot water heating modules there. We had a rain garden because we wanted to showcase that in downtown Columbus, even with such narrow lots, that we could take all the stormwater from the roofs of this project and mitigate it on site. So this whole project actually took a couple of years to build, and it's been very successful in the execution. So we'll talk about some of these features. I just want to walk you through some of these things to let you know that there's a lot going on here in Columbus. This is the AWARE program that the city of Columbus then was bold enough. They saw these projects, they saw Greenview Estates, they saw the success of it, they saw other projects coming online. So then what they did was that there was a neighborhood stabilization program. These were like tens of millions of dollars that Housing and Urban Development, the federal department, provided to cities around the country to be able to take abandoned homes in their neighborhood and be able to convert them. And so the city of Columbus decided that they were going to convert them into green homes. So AWARE stands for accessibility, water conservation, air quality, resource conservation, and energy performance. So those are the overarching goals. Now that spec is quite intense. I mean, it is probably available online, and it's several, like I would say 30, 40 pages deep. And it actually goes through and requires the contractors and the designers on the project to actually conform to various high performance design. So now going to the design, what is high performance design? Why is it important? Well, as you can see in the pie chart, the amount of energy that we use, there's a lot that we can achieve by restricting some of the space heating, right? So when you look at space heating or cooling, you're thinking insulation, you're thinking thermal bridging, you're thinking of like, what are you going to do if you have a basement? Your basement, you have walls that have complete, bridging with all the surrounding soil and the slab. That's a lot of heat loss. A basement slab, for example, is one of the highest heat loss source in a home. It can account to almost 30% of the heat loss in a home. We take that all very, that we want a basement, but when I talk to my clients anymore, I always ask them whether they really need a basement, because that's the most expensive storage space in the house. Expensive not only in terms of the cost of energy, it's durability, because it's going to be wicking in moisture depending on where you are sited. Most places you have those issues. So when you're looking at this pie chart, it really starts advising you about what you need to do, what you need to focus on. The lighting and the appliances part is a homeowner's task, right? I mean, that's there. You kind of inform the homeowners, you tell them about the technologies, the LED technologies, and all the different technologies, the appliances that are out there, amazing water sense fixtures, Energy Star fixtures. There's a lot out there, but they really can't help with the space heating, and that is the biggest component, I think, of design: space heating and cooling. Water heating, again, there are opportunities for using renewable. You can use hot water, solar hot water heating, but it really depends on the technologies you use. It's interesting because on a project that Bill is going to be talking about, we did geothermal heating and cooling system, which we required because there was no gas pipeline on site. So it was an all-electric home. But the issue there is that geothermal, the great thing about geothermal is it gives you free hot water in the summertime, because it's rejecting the heat from the house into the water. So you get free hot water. So all you need the hot water for then is in the wintertime. So what do you do? Like, how do you balance that? Because you don't get that free hot water from geothermal in the wintertime. But if you use the solar hot water heating, the issue there is that the effectiveness of solar hot water heating in the wintertime goes down dramatically because of the cloud cover and other issues. So when you need all your water during that particular time, what is the most cost effective? You could put that there, I mean, and that would be really remarkable, but is that the most cost effective option? So this really informs a design. Now, coming to passive solar, well, when you look at the energy usage in a traditional home in the United States, in 2014, the estimates was that an average home uses about 11,000 kilowatt hours per year, okay, 10,900, and change. So about 11,000 kilowatt hours a year. And when you look at Energy Star, that's about 15% better than traditional homes. When you're looking at passive solar design is a luxury in a way, because most of the lots that I work with, you don't necessarily have a south-facing lot. A client can come to me and say, well, I have an east or a west or north. Can I not build a high-performance project? Well, you can. You can build a really good high-performance project. South-facing, if you have a south-facing lot, you could, with your design, you could lop off about 1,000 kilowatt hours of that energy usage, like that 11,000 kilowatt hours. You can probably lop off about 1,000 kilowatt hours a year with that. Now, if you do windows and you do really efficient windows like triple pane windows, or if you do a good heat recovery system, you could lop off another 2,000 kilowatt hours. Okay, so when and these are figures that Building Science Corporation, which is it's not something that I'm talking about, it's something that they have researched and they have put it out there. And so this is Building Science Corporation research related numbers. And so when you're looking at these, when I look at design, when I look at a high performance project, I look at design as the cheapest way, the most cost effective way to make that reality happen. And then once that design, once there's nothing more that can be achieved in the design, then we move on to the technologies that's available for the site, that's available, you know, in that community or in that city. And we look at different options and saying which is going to be the most cost effective next, right? So, so when you're looking at passive solar design, one of the important things to understand in this climate is solar heat gain coefficient of your windows. A lot of people design homes and build homes thinking that, you know, you want a lot of sunlight, you want a lot of sun into your home during the whole year. But in the summertime, you're going to have a cooling penalty. You have a huge cooling penalty. And so how do you manipulate that? So you have to figure out, am I south facing, am I east facing? What is happening with my orientation first? And then you have to look at like overhangs to see if you're south facing, great. You have a latitude, you know, 40-degree latitude. You can plot the sun chart, you know, roughly it's about 2.5 feet of overhang that you need to block out some of the sun, so to be able to block out the summer sun, which is high up in the air, and then the winter sun, allowing that to come into your home, right? And so that's not an issue. But if you're east or west, then now you have an issue. You have a tremendous penalty, energy penalty in the summertime. And how do you do that? So you have to analyze how the project is going to behave through the whole year, through the whole, you know, 4 seasons. So, so that's the interesting challenge of passive solar. You know, getting it done right. How you're going to make that happen. One of the important technologies that's out there outside of the US is windows. The Germans and the Europeans have really mastered the whole concept of like weather stripping and, you know, really providing a window. Because when you're looking at the building envelope, when you're looking at high performance design, you're looking at the building envelope, right? First you do the design, you do the passive solar design. The next step is the building envelope. The building envelope has all these massive holes with these windows. So you have to address what are you going to do with these windows. So you know, there's technologies out there that say that, you know, your triple pane and triple pane glazing, double pane glazing with low E coatings, lots of technologies. But the interesting thing there is that you have to look at, like I said, the solar heat gain coefficient. You have to look at the U value, which is again the heat loss that occurs through the window with the glazing systems or the membranes that are there. Those are the major ones. Then you have something called the air infiltration value. I'll be talking a little bit about passive house design later on. Passive house design is really high, very, very low energy homes. Homes that literally can be heated with a hairdryer. Okay, you're talking about that kind of, you know, 1,800 square foot homes that can be heated with an 1,800 watt hairdryer. Okay. And so when you're going into those kinds of designs, then every little bit of because you don't want air infiltration in a house, right? That is the worst possible thing that you need to stop that. Why is it important? Well, first of all, yeah, I mean, it conducts, it takes heat, it goes through the envelope. But the most important thing that it does is that it will condense moisture right in your envelope, in your assembly, your wall assembly, which you will never see because you have drywall on the inside, you have siding on the outside. You don't know what's happening in your wall assembly, you know, through the life of its performance. So in the summertime, for example, you have moist, warm air that's coming from outside, and then you have cooling occurring in the house. Well, there's going to be a point where there's going to be a dew point where there's going to be condensation occurring in your wall assembly, and there's going to be moisture. And if you have materials in there that are cellulosic, then what happens is that is food for things to grow in it. So you have to really understand how when we're talking about high performance design, it's not just about like slapping insulation and saying, I'm just going to do this and I'm going to do that and I'm done. Well, now you might have created a problem. You've taken a problem, you thought you're going to create a solution. I liken it to the Bugatti Veyron, where they took this massive car and they have these radiators and water running to cool this engine. First of all, it's like burning so much energy. So when you're looking at windows, don't take this very easily, because North American windows, I mean, there are some that will have low infiltration, but air infiltration is one of the most important things in a high performance project. So this is about all the leaks that happens in a house, right? You can see here the biggest areas of concern are like all the roof, because most of our roofs is what, like attic spaces. So there's soffit vents that occur on these areas at the corners, and so there's wind washing that's occurring over your roof. And then unfortunately over here, this particular area, depending on how the wind washing is occurring, it is extremely susceptible, right, to heat loss, especially when you have trusses that are so close to this particular joist, the rafters here. So when you have these trusses so close to that there is really no room to insulate or to break that thermal bridging in that area, because you have the wall assembly going up, and then you have these trusses or rafters, right? So now you have something called the energy heal truss that you could use that will lift this up, for example, and then you're able to provide enough insulation in that space. The whole idea here is that when you're looking at the different leaks, but also look at the thermal bridging. Thermal bridging is really important in this drawing that you're looking here. You see the footing that's in contact with the soil. That's about 3 feet deep. But then really speaking, there will be heat loss, there will be conduction, because if you have a house that's being heated in the wintertime to like say 71 degrees Fahrenheit, and the ground temperature at best, I mean, you have to go several more feet deep to be about 55 degrees. You have to be 100 feet to be at 55 degrees for geothermal. But so you can assume that there's going to be a lot of heat loss occurring with that footing, because that footing is going right through that wall, the connection to that wall, and connection to all the interior spaces. Then you have the slab, the basement slab, or the slab on grade that you have on a home, and like I said, the roof, and then of course the walls, right? These are all the different aspects. Now, to give you an idea, when you're looking at, and I can show you this quickly. Let me pull this out. Okay. So this is International Energy Code, Conservation Code, and so what it's basically saying is that we are in Zone 5, right? So by building permit, if you design with building permit in mind, let me go down. These are the values, and I don't know if you can see them. Let me see if I can increase the size. So to kind of just give you an idea, if you go down climate zone, you have 5 and marine 4. That's where we fall under, and we look at a fenestration U factor, that's windows, at 0.32, and you come across and then you say wood frame wall R value, which is about 20, right? So when and basement is 10, the basement slab is 10 or 10. Now when you're looking at a low energy home, this is extremely leaky, and that's why I was when I talked about like homes that are designed, and when you're looking at 10,900 kilowatt hours, keep in mind that's only the electricity usage. It's not the heating cost, because we heat with gas. So if you do an all-electric home, you're talking about 17 to 18,000 kilowatt hours a year for pretty much all the energy usage in a traditional home. Now, if you look at these numbers and you design to these numbers, you will never get to a low energy home. I mean, this is an extremely leaky home. To give you an example of what we do in, say, a passive home. A passive home, a fenestration, the window U value, the lower the number, the better it is. Okay, so it's 0.35. We go down to 0.15. Okay, you could go to 0.17, 0.2. But that is the range that you are talking about. When you're looking at wood frame wall R value, the R value of 20. Now that's interesting, because the issue here is that builders will, what they'll do is they'll build stud walls, 2x6 stud walls, and they will put R20 insulation, because a 5.5 inch cavity will allow you to put R20 insulation. But then each of those studs is spaced at 24 inches on center. So you have a thermal bridge occurring at all those points, right, through the whole house. So when you do an energy analysis with all that thermal bridge, that R20 probably is about an R13 or 14. There is actually a research done by Oak Ridge Laboratory that kind of looks into a 2x4 wall and a 2x6 wall, and what is the actual whole wall R value performance. Okay. So, so when you're looking at R20 here, keep that in mind. So when we are looking at passive house or low energy homes, we are looking at an R value of 40. Okay, we are looking at roofs that to be like R60. These are super insulated homes, which also use passive design. I mean, that is definitely a free energy opportunity. The other aspect of it is this number at the bottom, which is the air changes per hour. That is how leaky is your home. Okay, so they have a blower door test. I don't know if you know that. I have seen it. It's just a door that's fixed into your front door. It's sealed in place. It's got like this giant fan, and they turn it on at about 50 pascals of pressure, and it blows air, and then they look at how much air is needed to kind of keep the balance between outside and inside, right? So as it leaks out, there needs to be a balance point. So when the balance point is reached, then you know how they calculate the air changes per hour. So in a home that's built to Energy Star, now remember, Energy Star is awesome because it is taking the standard up from building permit design. It is 15 to 20% better. When what Energy Star requires you is 3 air changes per hour. In a low energy home like passive homes, you are going down to 0.6 air changes per hour. It is dramatic. It is, it's really like there's research that talks about, building science talks about this, saying that they have brought down that 3 air changes per hour to 1.5 ACH. With production builders, with a lot of education and oversight and monitoring on site, there's a lot of work required. But the 0.6 is a pretty tough number to get. So, well, going back to, did it stop? Should I just say continue? Yeah. Okay. Okay. So, so this is giving you like the infrared camera picture of a house and telling you typically what are the areas that really are impacted with heat loss. All the yellow areas are areas that are showing dramatic heat loss. So you can see the windows, you can see the connection between the first story and the second story joists. Oh, I'm sorry. This space here, this whole band, this whole band area, and the windows, right? And any holes or any issues, maybe there's an electrical outlet, exterior electrical outlet. Maybe this is a front door, and so this is punctured in the wall. So you can see that, and like I talked to you about like the thermal bridging, there is something happening here. It could be that there is, there are panels, wood panels coming across, and somebody is not taped it correctly, and so there is like air loss, and so you can see that that's a big issue there, and which you wouldn't see unless you did this infrared camera imaging. So kind of walking through some of these. So we looked at how important it is to insulate these areas. We have come across technologies that like in the basement, the band board, the rim joist, this area, the connection between the first and second floor. These are all the leaky areas, and of course the windows, how they are flashed, how they are sealed, weather stripped, and how they perform is extremely key to how tight the project is going to be. And typically what I recommend, if you're doing a wood frame house, is to have spray foam insulation in these areas, because one of the challenges with a high performance house, and you're going green and environmental, is that I always feel that there's so many opportunities for entrepreneurial action to take place in this industry. And I've been talking about this for like over 15 years. And it's interesting because if you look at insulation, you look at spray foam insulation, it is harmful. It is extremely toxic. You look at, now you have cellulosic insulation that you can use in the walls, but typically like the fiber bats and all these, they all have toxins. So we're talking about air quality as an important aspect of green buildings, but then at the same time, our hands are tied because we really don't have these high performance materials that we need to kind of say comfortably that to a homeowner that you're safe and that you have a project that we're really proud of. The other aspect of it is siding. You have vinyl siding. I have nothing against the vinyl. I spoke at a leading manufacturer in Columbus. They invited me to speak, and they had a CEO there. And I talked about the harmful effects of vinyl, and I stand by it. And the next thing I know, I got calls from the vinyl industry in Washington, D.C., threatening me with a lawsuit. So it's interesting, what you can say about that. But the thing is, one of the issues that I feel is that you have, and this is something that living building, there's a living building challenge that is on the West Coast. They have created something called the red list. And so if you are building a home or a building or a commercial building, anything, you cannot use those chemicals in that red list. And it walks you through it. And one of them is PVC. Well, why? Because when it burns, it releases chlorine gas. And you don't even have to wait for seconds. It'll kill you instantly. You don't even have a chance to wait for firefighters and people to come within a few minutes. It'll kill you. So what I feel is that I like to use hardy board plank, siding, because that's more cementitious, or maybe wood siding, something like that. So looking at different options, but at the same time, these are opportunities for the industry to take on. These are just photographs of these homes that, this was a gut rehab project. It was very challenging in city of Columbus, in the Children's Hospital area. I designed the first two as that served. They did have done quite well, but it is challenging. You're taking an existing home and you're pretty much gutting it to its studs and then rebuilding. But then it has a lot of issues inside. You have fireplaces, you have a lot of infiltration between floor assemblies, and so you have to kind of look at all those problems. Now, one of the main things that people don't realize is, electrical outlets. You take electrical outlets in your exterior wall. It's required by code, but then it's actually taking out about 2.5 inches of space there, and no contractor is going to go back there and put insulation, tuck it in, and be so thoughtful that he's going to do that. So these are kind of like walking through all the areas that you really need to pay attention to in a house, especially plumbing, or vents that are going through. How are you going to place them, and how are they going to exit the house, and how do you design around that? So these are all, this is also talking about the ductwork in a house. You can see here really quickly, some people like to put their the cooling unit in the attic. They think, well, the cool air is going to drop down, but then you put that in the attic, you have all these, flexible duct things. There's going to be a huge heat loss occurring right there. The performance is going to come down dramatically. And then you have the furnace sitting here in the basement, but it's sitting on the slab, which is, again, a source of heat loss. So you have to keep in mind as to how are you going to make sure you bring everything within conditioned space. You don't want your furnaces and your technologies to be sitting in unconditioned space. Sort of walking through the duct, like the mastic and sealant that was applied on these projects, really things that you think happens but does not happen on site. You have to be there when the contractor is doing these things to make sure that they're actually doing, because they hate this stuff. They would love to get away from putting the mastic and the sealant. It's very sticky, so they would just put the mastic, not the sealant. So we would insist, hey, you have to do these two things simultaneously. Different types of insulation, like I said, cellulosic is one of them. A lot of options in the market today. I wish somebody would apply their mind and say that let's do something that's truly environmentally friendly, because cellulose, even though it is environmentally friendly, it depends on how you apply it. If you apply a dry pack, it's great, but then if you have to apply a dry pack, you have to put a mesh between your studs, because it's just going to fall off, right? So that's extra labor that they're going to charge you for. So a lot of people just do it wet pack. They just like dense pack cellulose in the wall assembly. But remember, you need time for it to dry. If the contractor is on a timeline to finish and the homeowner is like, come on, I need this yesterday kind of thing, then he's going to put that drywall. He doesn't care. He's going to put that drywall, but as a homeowner, you're going to have so much issues of durability if you are not thinking about that, right? So the other issue is, like, you have porches, right? People love having porches, attached garages. These are all unconditioned spaces. These are all projections that are occurring. These are huge thermal bridges, right? That are occurring right there. I mean, you might do a fantastic energy efficient house, but that alone will just knock out all your energy savings. So I'm trying to go faster here. So sorry. This is something that I love. It's called a heat recovery ventilator. It is really important to understand this. Linking, is that okay? I mean, can I take another couple of minutes and finish this? Or we're running low? Okay, okay. Okay, so I can talk about this later, because we did this for Bill's house. So talking about water usage, solar hot water usage, renewable energy, wind has become cost competent with coal. Anymore. I mean, I wouldn't talk about PVs and other technologies, but wind is really become really reasonable, and really interesting ways in which it's being used around the world. And then I'm going to skip this because we've done this in Bill's house. We can talk about this. It's about stormwater runoff and how it impacts what we do, creating all these impermeable sites by building on these areas, how we create issues. And this is actually in Sunbury. This is in Columbus. So this is not something somewhere in another part of the country. It's right here in Columbus. So going through the Energy Star. Energy Star is, like I said, the first step. The way I look at it is baby steps. First step is Energy Star, then you have LEED, then you have Passive House, then you have Living Building Standards. In terms of like how much torture you want to give to your designer. Like, it's like, okay, these are the levels of torture, like, in kind of like working through this. This is a passive house. You would think that a home that is so energy efficient. Now you're talking like, to give you a quick example, Energy Star is 15%. Passive houses could be 60 to 70% more efficient. We are not talking about net zero with the design. We have to do net zero with renewable. We can take the design to about 60, 70% efficiency, but after that, we do have to use technology to get it off the grid. But it's how much you can push it. So these are all the different organizations that have committed. The Urban and Land Institute, AIA's 2030 Challenge. I talked about the Columbus Green Building Forum. I serve as the executive director for this. It does outreach in education, and thank you.